TV. So we are going to do our theory of logarithm, JAMB class. So if you are writing mathematics in JAMB examination, then you are going to what? Face logarithm. So this first video on logarithm is going to be a relation between indices and logarithm. I'm going to look at laws of what? Logarithm, and how to solve simple problems. So this is what we are going to do in this video. Do you understand? So make sure you stick to the end of this video and take down every single thing. So the first one to look at is the relationship between indices and logarithm. I have done about 3 videos on indices. So if you have not checked out that video, please go and check out that video on indices. We have some many examples, a lot of indices, and some technical questions what indices. Do you understand? Now the first one to look at what relationship with. So that is what the first one to look at here. Now in indices here, we have b raised by x equals what n. How do we rewrite this one? This one is an indices what format. So how do we write this in what in logarithm format? Therefore, this one is the power, which is the index. Here is what is base. So here is what index. Here is what is base, and here is what is your value here. Now, if you want to write this one in logarithm form, it's very easy. So it's going to be what x, right? This x now will not come here equals what log. Then this base will also be what the base here raised by what n. So this is what indices format. This is what logarithm what format. Now let me give you a good example here. If for example you have 10 raised by 2 equals what 100, right? Normally 10 raised by 2 is equals to what 100. If you are being asked to write this one in what logarithm format, how do you write this in logarithm format? Now this one will come here 2 equals 2, right? You just say log. Now this base will also be a base here, then raised by what 100. Do you understand? So this one also is saying this one is the indices format, this one is what logarithm what format. If for example you have 2 raised by 6 equals to 64, right? 2 raised by 6 equals to 64. Remember, 2 times 2 times 2 to 6 places give you 24, right? So this one is the indices format. Now, how do you write it in what in logarithm format? It's very easy. So it's going to be 6 equals what log. Then these two that become in base raised by what 64. Do you understand? These are so this one is what logarithm format. This was indices what format. If you are being asked to express 4 raised by x equals to 256 in logarithm. How do you do this here? So if you ask now to express 4 raised by x equals to 256, and you are being asked what to express it in what in logarithm format, how do you do that here? It's very easy. Just so you can go ahead and try it if you can get the answer. So let's do it together here. So it's going to be x equals to what log, right? Log 4 raised by 256. That is it. So these are what the relationship. This is what the relation between what indices and what and logarithm. So now let's move to what. Let's move to laws of what logarithm. Now let's look at what various laws of logarithm. Now let's look at what the laws of logarithm. So now for you to solve any logarithm problem here, for you to understand the laws of logarithm, and there are 3 key laws of logarithm. We have what we call the multiplication law, the division law, and the word power law. So let's look at the first one here. Multiplication law. Again, in the multiplication law, you have log a, which is what m n. Is okay. So log of base a raised by what m n is multiplication law here. So whenever you have something like this, it's going to be what? How to separate it? It's going to be what log a capital letter M plus log a capital letter what n. This is called what multiplication what law. Do you understand? For example, here we have log 30c. So if I never have this one here, log base 630. Now, how do you simplify it here? Remember, 30, so this thing that was 6 times 5 or 5 times 6, right? So you can brace from that to be what? Log 6. 5 times 6. Can you see that? So this is where the multiplication is coming from. So 5 times 6 also gets on here. So when you evaluate it here, it's going to be log 6 raised to 5 plus log 6 raised to 6. Do you understand? So they are also essentially this other guy here. Do you understand? So if you have something like this, log 272. So can you evaluate this one for me? How do you evaluate log 272? Now, what number can we multiply to give me what? 72. If you look at the number that can multiply to give me what? 72 is what? 8 times 9. Just like 8 times 9. So it's going to be log 2, 8 times 9. Can you see that? So we also the same thing as what? Log base 2, 8 plus log base 2, 9. Also the same thing. Then you can now go further to what to evaluate it. Now, when you get to what normal problem question, you have to evaluate all these things. So you have to just understand this one here. Now, what about if you have something like this? Log 10 raised to 5 plus log 10 raised to 8. How do you evaluate it here? So you also the same thing as what? Log 10 5 times 8. Can you see that? So with 5 times 8, 5 times 8 is what? Is 40. So you also the same thing as what? Log 10 40. So now you can either go for multiplication to what? To multiplication, or to multiplication to what? To the addition. You get that? So this is what the first law, multiplication what? Law. Let me go to the next law. Look at what is called law number 2. Division law. Division law. Okay. In division law, here we have log a n over now let log b raised to what? N over what? N. Do you understand? So now when we have a division n over what? N over m, how do you evaluate it? So we're going to be equals what? Log b n minus, so the division will change to what? Negative sign, minus log b raised to what? N. So if for example you have log 2 raised to 8 over 3. Now what you have here is going to be also be seen as log 2 8 minus log 2 3. Can you see that? As easy as that one here. Like log 10, this one 100 about 3. So go ahead and evaluate this one for me. What's going to be the answer to this? Go ahead and do it. So here you are going to have log 10 is 100 minus log 10 is 3, right? So we can see evaluate from that, but just understand. I just want to understand these laws here. So what about if you have something like this? Log 3 raised to 81 minus log 3 raised to 9. Log base 3 81 minus log base 3 9. How do you evaluate it here? Now because here is minus sign, right? So when you combine, you're going to be log. Take the what? The what? Common base. Then raise to what? 81 over what? 9. So although you can still evaluate one further, but now let's leave it here. So this is how to what? This is what called what? Division what? Law. Now let's move to the next law, which is called the index law. Index law number 3. Index law. Index what? Law. Now in the index law, if you have something like this, law is log b raised to n raised to what a. This is called the index law. So where this number here have a what an index. So whenever I have something like this, so this will have to move down here to now have a log b n. Do you understand? So this is called the what the index law. For example, if you have something like this, log 3 raised to 9 raised to 2, right? Now this one here, that one is called the index law. So this power here we have to move down here to get something like this. 2 log 3 base 3 9. So we should also the same thing here. Now if you have something like this, 2 log 5 raised to 10, right? If you have something like this, if you want to write it here, you carry it back. So you have log 5 10 raised to 2. So this is what's called the index law. So these three laws of indices you must familiarize yourself there, because these are the place of you solving question or other what logarithm. You get these are what based when you can solve what logarithm what problem. So then you can what some simple logarithm problem you will easily see your what your JAMB examination. So let's get into it. So let's evaluate this one here, this simple problem. Now, but when we do that here, there are some special cases you need to what take note of when you're solving logarithm problem. So special case like this, log base a raised to what to the same log base raised to the same base. Now, if whenever I have log base raised to the same base, right? It's always equals to what 1. So you need to take note of this. If for example you have log 10 raised to 10, log base 10 raised to what 10, or log base 10 10, here we have what 1. Do you understand? If I have something like log 3 is what is 1. So you have what these are what special cases you need to what take note of. So whenever you have something like this, you have to it's always equals to what 1. So with that idea here, let's evaluate this one here. So you have log 7 49 raised to what a, right? Minus log 10 raised to what 0.01, right? So this is what I want in bracket here. But understand that I can break this thing down here, right? I can break this thing down. And I can also break it down. Remember, 49 is only thing that was 7 times. 7 thing that was 7 raised to power 2, right? And 0.01 is only thing that was 1 over 100. So these are things you need to what pay close attention to here, because if I want to remove the decimal point here, I will have what 100. So can you also instead of 1 over what 100. So when you divide, you also take it back. Now this one also things about 10 raised to 100 raised to minus 1, right? 100 raised to minus 1, which also things that what 10 raised to minus 2. So you have to evaluate for 0.01. Also things that what as 100. We also think that 1 over what 100. Now if you want to do it like this, you can also do it like this. 1 over what 100. Also think that 1 over what 10 raised to what 2, right? So if now this one is what is logarithm. If you want to change it to what, if you want to move this one to the other side here to numerator, you now have what 10 raised to minus what 2. So there are things into what taking off. Yeah, 49 is also saying about 7 raised to 2, and 0.01 also saying about 10 raised to minus what 2 here. Very important. So there are two things I want to what make use of here. Now, if you should impute it there, here you have log 7 raised to 2. You should have what a, right? Minus log 10. Now this operation here, I want to add so here, which is going to be give you 10 raised to minus what 2. Can you see that? So now if I should open this bracket here I have what log 7 raised to 2 what a, right? Minus log 10 raised to minus what 2. Now what yours have here? Now the other this one here, this one here is called index law. So move it down here. We have 2a log what? Log 7 right? Minus, remember there's minus here. When you move on here, we have minus 2 log what? Log what? 10. 10, right? So log 7 is what is 1. So it's going to be 2a, right? Times 1 minus times minus is what is plus, right? Plus 2 log 10 is what is 1. So we're going to do 2a plus 2. The answer is what is D. D is what is the answer, right? So if you just understand, you have to take step by step and follow it again and see if you are going to understand this simple calculation, right? If you're following, if you're not subscribed to the channel, please make sure you subscribe. And if you understand, please leave a comment section that you understand. If there's any question you want to ask, so also leave a comment section that you want to ask this question or ask question. I will respond to that. So let's move towards the next question. This question here we have two of them have base 10, base 10, base 10, base 10, numerator, denominator. So how do we evaluate this question here? Now, this one is under division law. Do you understand? So remember, in the division law, if I have something like this, log 8 over 3, 10, also saying about log 8, 10 minus log what? 10, 3, right? So the inverse is this one here. The inverse is this guy here. So it means that this one you are seeing here, log 10, 8 minus log 10, 4 is also the same thing as log 10, 8 over 4, right? Just the same thing if you check it very well. So the same thing here. Here we also have what? Log 10 raised to 4 over 2. If you checkmate it very well. So now what are you going to do here? So it's going to be log 8 over 4, 10 over what? Log 10, 4 over 2. If you, now 4 going to 8, so you have log 10 raised to what? 2 over log 10 raised to what? 2, right? Because 4 going to 8 is what is 2, 2 going to 4 is what is 10, right? So what happened here? This guy will divide this guy, you should also see it as 1. So the answer is what is E. That is the answer. How do I evaluate this question here? Common JAMB question. So here we have log 2 4, log 4 2, and log 25 5. Now they all have different base, so we cannot combine them together again. But however, I want to say I can reduce this one, reduce this one, and reduce this one here. So now let me see how the base and this one can be the same, right? So if you check me very well, if I want to have if I want to reduce one to what to make it have this 2, you're going to do what? Remember, 2 raised by 2 is what is 4, right? 2 raised by 2 is what is 4, right? So here I'm going to have log 2 raised by 4. It's also the same thing about as log 2 raised by 2 raised by 2 here, right? Log base 2, 2 raised by 2. Now, the same picture other way. If you have something like this, if I want to what, change this one to what 4, like I want to ensure that I have 4 here, right? Now it's going to be 2. Now log 4 raised by half equals to what 2. Just as log 4 raised by 2 is what is 2 here. Why? Because the square root of 4 is what is 2. So now instead of me placing 2 here, I will place what 4 raised by 1 about 2, which was the square root of 4. Using here. Now, that's what I'm still going to do here. Now, 25 raised by 2, raised by 1 over 2, that is the square root of what 25, I have what 5. So now when you're solving in this, now when you're solving this kind of problem here, you need to what reason very fast and see how you can what easily what get this what your values. So if I should replace log 4 here to be what 2 raised by 2, so I will write stuff here to be log 2 2 raised to power 2, right? So log 2 raised to power, this 2 raised to power 2 also the same thing as this guy here. I'm rewriting stuff again. Plus log 4, right? Now, here 2, 2 is also the same thing about 4 raised to power 1 about 2, right? Or 4 raised to power 1 about 2 also the same thing about as 2. So that's not me writing 2 here. I will write 4 raised to power 1 over 2. So going to be 4 1 raised 4 raised to power 1 over 2, right? Minus log. Here we have 25 here. How do I get 25? It's going to be 25 raised to power 1 over 2. That is it. So what I want to do here is to what? Carry something. Now this one is now what? Index law or power law. So carry from here we have 2 log 2 to my plus. Next one here, 1 over 2 log what? 4 minus log, here we have half log 25, right? Remember I told that log of base of that base is okay, is what is 1. So log 2 is going to be what? 1. So it's going to be 1 and what? 1. So it's going to be 2 plus half minus what? Half, right? So what I want to do here is to what? Evaluate this one. If we should evaluate it here, what is my LCM? So what is my LCM? My LCM is what? Is 2, right? Here is 1. So just do a normal evaluation here. 1 going to 2 is what? 1 going to 2 is 2. 2 times 2 is what? 4 plus 2 going to 2 is what? Is 1 minus 1. So what are you going to get here? 1 minus 1. So here we have 4 over 2, which is going to be 2 here. So we have 2. So A is what? A is what? Answer. So now this is just the first video on logarithm here. This is just a simple, questions or problem here. Now in my next video, I'm going to look at what more advanced questions when it comes to what logarithm. So if you're not subscribed to the channel, please hit the subscribe button. If you have not liked this video, please give it a like. Please kindly share this video to your friends and your friends or your siblings who will be needing these videos. Here we create math, chemistry, and physics video. So I have a playlist on chemistry in JAMB, a complete playlist here, so you can go check out that video. Thanks for watching. See my next video.